Imagine a world where emotions are contagious, where simply witnessing a smile or a frown can make you feel a surge of happiness or a wave of sadness. This phenomenon is called emotional contagion, and it's like catching feelings through the power of embodied simulation. Our brains are wired with mirror neuron systems that help us internally mimic what we see, hear, or feel, creating a kind of neural mirror that reflects others' emotions and actions. When we vocalize our gestures, our motor planning kicks in, engaging motor cortices and premotor areas, making us physically respond to emotional cues. Whether it's a sympathetic smile or a comforting hug, these actions are part of our intramodal and cross-modal processes, whereas our brain integrates different sensory inputs to understand emotions, sometimes even in amodal ways that transcend specific senses. This neural mimicry fuels empathy, which we can think of as emotional resonance with others. Empathy isn't just feeling what someone else feels, it involves perspective taking and cognitive empathy, where we try to understand their mental state, and effective empathy, where we actually share their emotional experience. The cingulate cortex, insula, and anterior insula are key players here, processing affective and perceptual aspects of emotion, while regions like the medial prefrontal cortex and temporal parietal junctions helps us with mentalization, the ability to infer others' thoughts and intentions. Our brain's perception action loop, involving bilateral frontal parietal loops and the temporal occipital lobes, supports this intricate dance between perceiving and responding. The amygdala, often called the brain's emotional alarm system, activates during both positive and negative emotions, influencing our emotional reactions and social judgments. The thalamus acts as a relay station, modulating signals between cortical and subcortical structures, helping us process internal sensations and external stimuli. In understanding others, we rely on a suite of cognitive strategies like empathy, imagery, and reflection, which allow us to simulate and interpret emotional states. The fusiform gyrus and inferior parietal lobe assist in recognizing faces and gestures, while the superior parietal lobe and supramarginal gyrus contribute to our sense of bodily awareness and motor resonance. All these processes are part of a broad emotional circuit involving cortices and subcortical structures working together seamlessly. When empathetic reactions occur, they often involve motor representations like the levator labii superior's muscle, which helps us smile, or the muscles involved in frowning, showing how emotion and action are intertwined. However, in conditions like schizophrenia, depression, or PTSD, this delicate balance can be disrupted, leading to vivid emotional trauma memories or difficulties in emotional regulation. Autonomic arousal and interoceptive awareness, our sense of internal bodily states, play crucial roles in how we appraise and control emotion, influencing our capacity for empathy and social connection. So next time you catch someone smile or feel a pang of sadness watching a movie, remember it's all happening in a complex, beautiful, choreographed neural symphony where motion, cognition, and action come together in a dance that makes us human.